The first question is, a company runs a legacy application on an Amazon EC2 Linux instance. The application code cannot be modified and the system cannot run on more than one instance. A solutions architect must design a resilient solution that can improve the recovery time for the system. What should the solutions architect recommend to meet these requirements? You have got four options. This is your option 1, this is your option 2, this is your option 3, and this is your option 4. You have 10 seconds time to answer the question and your time starts now. Time up. Now let us analyze the answers. This is option 1. Launch the EC2 instance with 2 Amazon EBS volumes and configure RAID 0. This option is incorrect because configuring RAID 0 with 2 EBS volumes would provide improved performance, but it wouldn't improve resilience or recovery time. If one volume fails, the data would be lost. So option 1 is not the correct answer. Option 3. Deploy the EC2 instance in a cluster placement group in an availability zone. This option is also incorrect because deploying the EC2 instance in a cluster placement group would improve network performance, but it wouldn't provide resilience or improve recovery time. So option number 3 is also not what we want. Wrong answer. Option 4. Create an Amazon CloudWatch alarm to recover the EC2 instance in case of failure. Also incorrect because creating an Amazon CloudWatch alarm to recover the EC2 instance in case of failure would help to detect issues, but it wouldn't provide resilience or improve recovery time on its own. So option number 4 is also the wrong answer. Option 2. Launch the EC2 instance with the 2 Amazon EBS volumes and configure RAID 1. This option is correct because configuring RAID 1 with 2 EBS volumes would provide redundancy, improving resilience and recovery time. If one volume fails, the data would be still available on the other volume. Right. So option number 2 is the correct answer for this question. Okay, let us move to the next question. An organization has a large amount of data on Windows file shares in their on-premises data center. The organization would like to move data into Amazon S3. They would like to automate the migration of data over their AWS Direct Connect link. Which AWS service can assist them? You have again got 4 options. This is option 1, this is option 2, this is option 3, and this is option 4. You have 10 seconds time and your time starts now. Time up. Now let us analyze the answers. Option 1, AWS CloudFormation, is incorrect as AWS CloudFormation is a service that helps you create and manage infrastructure resources such as EC2 instances, S3 buckets and more. While it's great for automating infrastructure deployments, it's not designed for migrating data from on-premises file shares to S3. Okay, so option number 1 is the wrong answer. Option 3, AWS Database Migration Service, which is DMS, also incorrect because DMS is like AWS DMS is a service that helps you to migrate databases from on-premises or other cloud providers to AWS. While it's great for database migrations, it's not designed for migrating data from file shares to S3. So also option 3 is also the wrong answer. Okay, option 4, AWS Snowball. This option is also incorrect because AWS Snowball is a service that helps you migrate large amounts of data to AWS using physical storage devices. While it's great for migrating large data sets, it's not designed for automating data migrations over a network link like AWS Direct Connect. Okay, so AWS Snowball is the wrong answer. Option 2, AWS Data Sync, is correct. Why? Because AWS Data Sync is a service that helps you migrate data from on-premises storage systems including Windows SMB file shares to AWS storage services such as S3. It automates the migration process and can use your AWS Direct Connect link for fast and secure data transfer. Okay, so option number 2, AWS Data Sync, is the correct answer for this question. Okay, let us move to the next question. An AWS organization has an OU with multiple member accounts in it. The company needs to restrict the ability to launch only specific Amazon EC2 instance types. How can this policy be applied across the accounts with the least effort? You have again got 4 options for this question. This is option 1, this is option 2, this is option 3, and this is option 4. You have 10 seconds time. Your time starts now. Time up. Now let us analyze the answers. Option 1, create an SCP with an allow rule that allows launching the specific instance types. This option is incorrect because creating an SCP with an allow rule might seem like a good idea, but SCPs are designed to deny actions, not allow them. Allow rules in SCPs can actually have unintended consequences. Okay, so option number 1 is the wrong answer. Option 2, create an IAM policy to deny launching all but the specific instance types. This option is also incorrect because creating an IAM policy to deny launching all but the specific instance types would require you to attach the policy to every IAM user, role or group in every account. This would be a lot of work and could lead to errors. Okay, so option number 2 is the wrong answer. Option 3, use AWS Resource Access Manager to control which launch types can be used. This option is also incorrect because AWS Resource Access Manager, which is RAM, is a service that allows you to share resources across accounts, but it's not designed to control which EC2 instance types can be launched. Right? So option number 3 is also the wrong answer. Option 4, create an SCP with a deny rule that denies all but the specific instance types. Now this option is correct because creating an SCP with a deny rule that denies all but the specific instance types is the best approach. SCPs are applied at the organization or OU level so that you can apply this policy across all accounts in the OU with minimal effort. The deny rule will ensure that only the specified instance types can be launched. Okay, this is why option number 4 is the correct answer. Got it? Let us move to the next question. As solutions architect for a large banking company is configuring access control within the organization for an Amazon S3 bucket containing thousands of financial records. There are 20 different teams which need to have the access to this bucket. However, they all need different permissions. These 20 teams correspond to 20 accounts within the banking company who are currently using AWS organizations. What is the simplest way to achieve this whilst adhering to the principle of least privilege? Okay, so this was your question. You have got 4 options. 5 options actually. This is option 1, this is option 2, this is option 3, and this is option 4. Oh, you have got 4 options. Sorry. These are the options. It's a little bit difficult to navigate through the options. So if you want some more time than 10 seconds, you can take your time, but we are going to follow the standard timer itself, which is 10 seconds. Your time starts now. Time up. Now let us analyze the answers. Option 1, create a new AWS organizations, assign each team to a different organizational unit and apply to appropriate permissions, granting access to the appropriate resources in the bucket. This option is highly incorrect because creating a new AWS organization and assigning teams to organizational units is a good start. However, applying permissions to access the S3 bucket would require additional configurations such as creating IAM rules or bucket policies, right? So option number 1 is the wrong answer. Option number 2, copy the items from the bucket to create separate versions of each. Separate the items in the bucket into new buckets. Administer bucket policies to allow each account to access the appropriate bucket. This option is also incorrect because copying items to create separate versions and separating them into new buckets would result in data duplication and increased storage costs. Administering bucket policies for each account would also add complexity. So this is why option number 2 is also not the correct answer. Option 3, create the S3 bucket in an individual account. Configure an IAM role for each user to enable cross-account access for the S3 bucket with a permissions policy to only access the appropriate items within the bucket. Okay, this option is also incorrect because creating an IAM role for each user to enable cross-account access would result in a large number of roles to manage. Additionally, configuring permissions policies for each role would be complex. We don't want that. So option number 3 is also the wrong answer. Option 4, use S3 access points to administer different access policies to each team and control access points using service control policies within AWS organizations. Okay, this option is correct because using S3 access points to administer different access policies to each team is the simplest way to achieve this, because access points provide a centralized way to manage access to the S3 bucket. Controlling access points using SCPs, like service control policies, within AWS organizations ensures that the access is granted according to the principle of least privilege, right? So this is why option number 4 is the correct answer. The others are wrong, as you can see. Right, let us move to the next question. This is the last question of this video. Okay, a company is architecting a shared storage solution for an AWS hosted gaming application. The company needs the ability to use Lustre clients to access data. The solution must be fully managed. Which solution meets these requirements? You have again got 4 options for this question. This is your option 1, this is your option 2, this is your option 3, and this is your option 4. Got it? It's again a little bit difficult to navigate, so you can take some more time if you want. Your timer starts now. Time up. Now let us analyze the answers. Option 1, create a file gateway with AWS Storage Gateway. Create a client-side file share using the required protocol. Share the file with the application server. This option is incorrect because AWS Storage Gateway's file gateway doesn't support Lustre clients. It supports NFS and SMB protocols but not Lustre. So option number 1 is the wrong answer. Option 2, create an Amazon Elastic file system, like Amazon EFS file system, and configure it to support Lustre. Attach the file system to the origin server. Connect the application server to the file system. This option is also incorrect because Amazon EFS supports NFS protocol, but it doesn't natively support Lustre clients. Why it's possible to use EFS with Lustre? It's not a fully managed solution. Okay, so option number 2 is also the wrong answer. Option 4, assign the AWS data sync task to share the data as a mountable file system. Sync the file system with the application server. This option is also incorrect because AWS data sync is a service that helps transfer data between storage systems. While it can help sync data, it's not a file system solution that supports Lustre clients. So option number 4 is the wrong answer. Option 3, create an Amazon FSx for Lustre file system. Connect the file system to the origin server. Ensure that the file system is connected to the application server. This option is correct because Amazon FSx for Lustre is a fully managed service that supports Lustre clients. It's designed for high performance computing and machine learning workloads, making it a great fit for gaming applications. Okay, so option number 3 is the correct answer, and you can see the others are wrong. Congratulations for successfully answering 5 questions in today's video. I hope you liked the questions. If you did, then please make sure to leave a thumbs up and subscribe to AMG Cloud. We have more questions like these for AWS Cloud Practitioner and AWS Solutions Architect as well. They are in separate playlists. If you want to practice, you can go there and do so. That's it for today's video. I'll meet you in the next video with a new set of questions. Till then, keep learning, keep practicing, and keep exploring. Thank you and bye-bye.